So we're reviewing for the test, and I just asked the kids, where is 5 pi over 6? Steps in my head would be, well, this is where pi is. And 5 pi over 6 is 5/6 of the way there. So the first thing I'd try to figure out, instead of 5 pi over 6, is where's 1 pi over 6? That's 1/6 of the way. So that's about there. So that's 1 pi over 6. And then I would count them up. And I'm going to pause the video for just a second. All right, so that's 1 pi over 6. 2, 3, 4, 5 pi over 6. Okay, so I'm guessing most of you got that right. Please tell me you got that right. Raise your hand if you had that one right. Okay, good. Next one is draw the triangle that goes with that. It's called a reference triangle. So that if you needed to answer sine of 5 pi over 6, that you'd be able to do it. So draw the triangle around that. A quick reminder that I am going to be in for morning help tomorrow. It's normally Thursdays, but today, for this week, I am going to be here for you tomorrow. An extra help day. So I will be in both Tuesday and Thursday of this week because of the fact that you have this test. So that could really give you an extra boost. If you're like, oh, I'm nervous about this test, please come in. I've had kids come in with C knowledge and they walk out of here with A knowledge. Just a little extra tuning makes a big difference. All right, I know you all knew this, and you knew that this was 30 and this was 60. And then I think you know that this is 1, 2, and the square root of 3, but what's the oops? What should be negative? The square root of 3. So those are your key numbers. Now I got it all labeled. Yay. So which of these is the reference angle then? That one is. That one's the reference angle. And now let's just answer the question. What is sine of 5 pi over 6? Then you got to jump to SOHCAHTOA. Sine is opposite of right hypotenuse. Do 1/2. Raise your hand if you had that one right. Okay, good. We're good so far. Now what if I went backwards? And what if I said sine of what is 1/2? Do you get, I just did this problem and we know the answer is 5 pi over 6. Like we already know that. But how could you have done it? Like what would you have done? Well, and I would have gone like this. Everybody draw a triangle. Just draw a normal triangle. Not even in the context of the whole circle. Just a normal triangle. And then put the angle right here. I always like to, I think that's the easy spot for it. Not the up high one, but the down low one. And then we know sine is opposite of right hypotenuse, right? So we can slap in, that's 1, that's 2. And we can figure out that third side, and you know it. 1, 2, oh yeah, square root of 3, I know that one. Notice it's not negative this time. Doesn't need to be. Why? Because we're just drawing a normal one. We're in the first quadrant. We don't have to do it in the other quadrant. And then, what's the angle? And you should be like, oh, I know this one. What's across from the 1? That's a 30. So then this must be 30. Would that be an okay answer? Yes, unless they said answer must be in radians. So 30 is a good answer until you go, oh wait, that's not radians. And this is one of the ones I said to memorize. And they're right here, but they're not going to be there on the test. 30 is pi over 6. So you should have that one memorized. So if they needed radians, pi over 6 would have been the right answer. Get how I put that together? That's hard for a lot of kids. We should practice that one. I'm going to give you another one. Draw a triangle. And this time I'm going to say, not sine, but like one of the sister functions of that. So I'm going to do secant. Now, do you remember which sister function that is with? Maybe you should take a second and write down sine goes with this, cosine goes with that, tangent goes with that. Just take a second, refresh your memory on those 6 sister functions. In fact, I'm just going to make that part of this problem. Everybody write that down. Sine of this goes with what? cosine goes with what, and tangent goes with what. That's the 6 functions. That's another thing that's on this test. Because like right now, if I say secant of this thing is 2, you'd have to be able to go backwards and go, okay, so you're really saying use this sister function. So here's one of the 20 little things you have to know for this test. That sine goes with CSC, cosine goes with sec, and tangent goes with cotangent. If you don't know those, you don't have a chance at this. But now that I've said that, you should be able to go, okay, so then I guess you're telling me you can peacefully refuse to do secant and instead do cosine. But it won't be 2. What'll it be? 1/2. Now do the problem. Now, I broke one of my rules. I said when you make a triangle that you don't know how big the sides are, that you should make it is a short, fat triangle so that you can be more believable about like which sides are certain lengths. Because if I make it long and skinny and then by accident the long side is on the short side of the triangle, see, make your triangle short and fat, so you may want to fix that. And let's make this the angle. Can you finish this question? What is the question even? Well, where's the variable? That's the thing we don't know. We don't know theta. So figure out what angle that has to be. Is it 30? Is it 60? Is it 45? Those are pretty much always the answers. 30, 60, or 45. Because we haven't made you memorize like sine of 22 degrees. You know, like we only make you memorize 30, 60, 45. And as we get further into trig, you'll memorize a few others. All right, so talk me through this. I'll take a volunteer on this. I got to put some numbers on some sides. That's what I'm saying. That's like the next thing to do. Tully, you know how to do it? If not, I'll ask somebody else.
Like, you want me to do like the 1, 2, 3?
Yeah. Tell me where those things should have to go.
So 2 is the hypotenuse.
That's the hypotenuse, yup.
The 1 is in between like 90 and the 60.
All right, so the 1 has to go like here. Is that what you mean? See, that's the thing. Which one is it? So cosine, you got to go back to SOHCAHTOA. One of the 20 things you've got to know. SOHCAHTOA kicks in, and cosine means ka. So what is it again? Come on, Tully, what does ka mean?
Oh, adjacent over hypotenuse.
Yep.
So the 1 is...
Did I put it in the right spot?
Yeah.
Yes, I did. That's where the 1 goes. Because they gave me the adjacent. And they said the adjacent was 1. So this is where adjacent goes. That's the only place adjacent can go. It can't go on the hypotenuse, of course. All right. So then it's 1, 2, square root of 3. Because why? Because always. They're in a 30, 60, 90. All right. And now cosine is adjacent over hypotenuse. So that's, what do they want? I've got it all labeled. What do they want? Like, what's the answer?
Oh, cosine of 30. No, cosine is 60.
This would have to be a 60? You are correct, because the 1 is across from the 30. And they wanted to know what the angle was. The angle must have been a 60. All right, I think we should do another one of those. So, sine of some angle is root 3 over 2. What's the angle? We've already covered about half the stuff that's on the test. but this is one of the toughest things. Like I can tell, this would be one that would bother you guys. Now, some people got here late, but just a quick reminder, cell phone should be away. Headphones need to come out. I'm making Alex is absent today. If you're actually here, say something. And Anna. Alex and Anna. Okay, so you should have drawn a triangle, and remember my advice, make it a short, fat triangle, because you don't know whether you got a 30, 60, 90 or a 45, 45, 90. And if it's a long, skinny triangle, you can confuse yourself. Put the angle theta here. Now, you try to figure out what goes where. Do you remember that sine is opposite over hypotenuse? So they gave me the opposite side, square root of 3, hypotenuse side, 2. Oh yeah, 1, 2, square root of 3 again. And across from the 1 is where the 30 goes. Is the 30 the answer then? No, we want this angle, which must be 60. If you wrote 60 on the test, I'd cry a little bit and mark it wrong because they're going to ask you for radians. Take a second, see if you remember what the radians is for that. What if you're bad at converting those? That's on the test too. If you can't make 60 into radians, you're going to lose some points on the test because they're going to say, do you know how to multiply this by pi over 180? Remember that deal? Day 1, I said, if you don't remember that pi is 180, you're toast. Got to remember that one. So then the degrees cancel, and then this is 60 pi over 180, cancel some stuff. 6 over 18, ooh, I can do that. 18 is 6 times 3. 6 is cancel, it's pi over 3. Pi over 3. And that's the final answer if you need radians. Pi over 3. I need to know if you're confident on this kind now. Give me a 5 if you're confident, a 1 if you're not at all. All right, good. Let's move on to a different kind then. So what if I give you a triangle and I give you 2 of the sides? This side's going to be the square root of 13, and this side's going to be 2. And all I asked you for is what's the third side? There's a way. Sophia, do you remember that thing where I said start with a square root and then you square both of these?
Oh, yeah.
That's an important thing to remember. So what if you square 2? Well, that's 4. What if you square the square root of 13? Well, it means square root of 13 times square root of 13, so it makes 13. And is this the longest side of my triangle? No, so you minus them. So square root of 13 minus 4. So that would be square root of 9. And then what's square root of 9? 3. Be honest. How many of you got the 3? Raise your hand if you had the 3. Okay, that's only half the class. We should do another one like that. So we're going to do, this is 5 and this is 1. What's this side then? It goes quick if you remember that process. Spencer, tell me that process again. 25.
And then, minus one.
Okay, and then what? Don't forget to start
Do
square root. So then it's square root of 24. Raise your hand if you had square root of 24, or you simplified that. Okay, good. And the square root of 24 should be simplified because it's root 6 and root 4. And that one works out nice, so it's 2 root 6. Okay. Now the reason we do these is not just to find the third side of a triangle. Frankly, that's geometry. You did that in geometry. Same exact thing 2 years ago. So why would we do this? Because we might have told you to find cosine of that angle, and do you get, we didn't have the 3 yet, so we couldn't even do it. You know, like I gave you these two numbers, you would have to figure out the 3 first, and then cosine will be easy, it's just adjacent over hypotenuse. So what is the cosine of theta? It is adjacent, which is 3 over hypotenuse, square root of 13. Okay, do you remember rationalizing? What could you times this by on the top and the bottom? Square root of 13. Why would that be any good at all? Because that doesn't have a square root anymore. It's just 13. And on the top, it's 3 root 13. You got to know about that. Here's the reason that that matters. If you have 1 over root 2, would you please rationalize that? Because the answers look so different. There's another right answer for this. It's root 2 over square root of 4, which is 2. Who had root 2 over 2? Okay, cool. Now, why does that matter? Because if you're in a triangle that would have been the 1, 1, root 2 triangle, do you get it's legal to divide everything by root 2? Does that make sense to you, first of all? Can you do that? Yeah, you can take all the sides and divide by something. Now that turned into 1. Yay for that. That's the simple part. But then these are kind of gross. And these would be rationalized. So that means you've got this is a strange looking triangle that's still a 45, 45, 90. It's root 2 over 2 here, and root 2 over 2 here, and a 1 there. Do you get that any triangle that's a right triangle like this, where the sides are equal on the 2 sides are equal like that, it must be the 45, 45, 90. You have to recognize that, oh, that's got to be a 45, 45, 90. Even though it's not 1, 1, and root 2 like I was expecting, if these two are the same, wait, if this and this are the same, that's got to be a 45, 45, 90. So even if it's like 8, 8, and some weird thing over there, yeah, that's a 45, 45, 90. I know it is. Why? Because this angle and this angle have to be the same because they have the same side across from them. They must be 45, 45s. Okay. Next one. 3. 5. There's the key angle. What's the sine? What's the cosine? What's the tangent? But I don't have the third side. We'll figure it out. And then, what are these 3? And what are they equal? So you should know the sister functions. Man, a lot to know on your first test. Let's say that you're doing the homework tonight and you're really shaky on it. You have 2 choices then. You either have to study longer tonight, or you finish the homework but you come in the morning and you get help. But some of this is just plain old-fashioned memorize. Like, check. Sine goes with, just memorize. Cosecant, very good. Row 6, there's nobody there. Row 3, last person, Effie. Cosine goes with which one? Secant, very good. And then the last one's easy. Tangent goes with cotangent. And then sine, I can do sine without even finding the third side, because sine is opposite over hypotenuse. Opposite from there, you know? So 3 over 5. And that means I can do cosecant, 5 over 3. It's just a flip. But I got to find that third side, and I would go square root of 25 minus 9. And then I'd quickly realize, oh, that's the square root of 16. It's just 4. I should have known that that was a 3, 4, 5 triangle. And now I can answer the rest of them. Cosine is adjacent over hypotenuse, 4 over 5. Tangent is TOA, opposite over adjacent, 3 over 4. And then I just got to flip these. 5 over 4 here, and 4 over 3 there. Feel like you could do that? All right, good. Then here's not the last one, but we're getting into the most like deep. First, do you know that an equilateral triangle has all the angles are the same? And that means you know what they are. If you can use logic, and you know that has to add up to 180, you should automatically know what kind of triangle this is. So everybody right now, figure out how many degrees they are and label them. Like if you think they're 45s, I'm a little sad for you, but then you do this, but that'd be wrong. So label all the angles in there. Because then I'm going to give you more info. I'm going to tell you this side right there, straight up and down, dividing this exactly in half. I know it's not, the drawing isn't perfect, but that's going to be 5. Now you can figure out how long these sides are. I'm going to call them, x is a bad variable because it looks like a time sign. N. All the sides are the same. So label everything you know. You know a lot of things. You know like 6 angles up there. Seriously. If I wasn't clear about this, this is going straight up and down, dividing it exactly in 2, which means those 2 angles are both 90s. And if this is a 60, 60, 60 triangle, that's got to be 60, 60, and these 2 must be 30. Do you get I actually have a 30, 60, 90 triangle? Okay. So again, I'm asking you to figure out n. So you should be going, okay, I guess I got to do trig, because it's the whole unit's called trig. So maybe I should do sine, cosine, or tangent of one of the angles. And I personally like to use the angles that are down low. It makes more sense to me to figure out opposites and adjacents and all that stuff. So I would look at that and I would figure out, is it sine of 60 that I want to use? Or is it cosine of 60? Or is it tangent of 60? It's only one of those 3 that actually makes any sense. Garrett, which do you think it is? Sine, cosine, or tangent that is the one we need?
Sine.
Because why?
If we can
opposite, and hypotenuse, and so sine's the one. You are correct. Sine of 60 is 5 over n, and that's a great equation to write, and I would just be like, oh, kid got so close. You just had to solve for n. So, solve for n if you haven't already. See, precalc isn't really super hard. It's about drawing triangles, figuring out, using logic to go, okay, I know, I guess all those are 60, 60, 60, because it's an equilateral. Just tons of little things. And the next little thing is, do you know how to solve that? Row 2, and this one is Nate. Tell me, how do I get this n out of here so that I can get it solved for n?
So you times the 5 over n by n.
By n.
That cancels. You put the n on the other side, then divide sine of 60.
Divide by sine of 60 now, because this n needs to be alone, and the thing that's by it is the sine of 60. So n equals 5 over sine of 60. But can you leave your answer that way? No, because you know what sine of 60 is. Out of the 20 things you got to know for this chapter, one of the little ones is draw a 30, 60, 90 triangle. And make it short and fat. I keep on making that mistake, and I was about to have to label that in a way that would have been basically wrong. One, 2, square root of 3. Make sure I'm doing that right. 1's across from the 30. Yep, okay. So then sine of 60. Sine is opposite over hypotenuse is root 3 over 2. Next of the million little things you have to know is if you have a fraction over a fraction. 5 is like 5 over 1. Then it's 5 over 1 times, flip this one, 2 over root 3. So that's 10 over root 3. Can you leave it that way? Yes, you can. Could you also rationalize it? Yes, you could. Some super smart kids are going to be like, I'm going to multiply by square root of 3 over square root of 3. And you don't have to do it. And there's my answer. Okay, here's another one that's similar. You got a square, aka all the sides are the same. That angle right there has a length of 11. And the question is, how long are those sides? Remember, I know it kind of looks like a rectangle. It's not, it's a square. If it's really a square, you know a really important things about the angles, you should be able to solve this problem without my help. I'll pause for a second. Stay focused. We're half hour in. Another 10 minutes, we'll be done. And this is super critical for your test. All right. Row 3, second to last. Jaden? Nope, wrong. Sorry, couldn't see your face. Greta, can you tell me what are the sides? Oh no, don't tell me the final answer, sorry. Tell me, since I know all the sides are equal, what does it tell me about angles?
The angles are the same, which is 45.
Okay, wait, these are 90 though, right?
Yeah.
And so the key angles are, these are 45 each. Yup. Okay, so now that was critical. So now you got to do trig, because the point of this whole unit is trig. So we got to figure out how long that is. So I'm going to call it n. And I don't know, where'd you put the n? Greta, did you put it on the top or on the side, left side, right side?
I put it on the right side.
Okay. And you could do it either any place because it doesn't matter. You know, like it's just they're all the same. So if we're gonna do it that way, tell me the trig part now.
Sine of 45 degrees is the angle of 11.
Now if some kid was trying to do cosine, that would have worked too. Because then it would have just been down here. And that would have worked too, which is weird, but it's true. In this problem, you could have done sine or cosine. The one that wouldn't have worked would have been tangent. Even actually, that would have worked if you would have really known what you were doing, but I probably think most of you picked sine or cosine. All right, and then next is how do I solve that thing? Mason, can you tell me what to do to get that n alone?
Times 11.
Yep, and then n is alone. Cool. Why can't I leave it that way?
Because you have to find sine of 45.
You got it. So let's find sine of 45. I would draw the classic 1, 1, root 2 triangle. And somebody's going to tell me sine of 45. This is row 5. And that one is Spencer. Can you tell me the sine of 45? I would have used this one. Yep. So then you replace this with 1 over square root of 2. So it's 11 times that. I'm surprised how many kids don't know how to finish this. But 11 is 11 over 1. So then you just times them across the top and the bottom. It's 11 over root 2. What will some smart kids do? Rationalize. Do you have to? No. But you can. And then it'd be 11 root 2 over 2. But if you left it as this, I'm okay with that.
Mr. Server,
Oh,
should
uh-oh.
you flip it so it shouldn't be root 2?
Wait. Why should we flip it?
Well, you flipped it.
I'm confused. Oh, hold on just a second.
It's the fraction.
Wasn't sine of 45 1 over root 2?
1 over root 2, but when you divide a fraction by a fraction.
We are not dividing. No, we are not dividing.
So wouldn't it be,
Wait, isn't this 11 times the sine of 45? And if the sine of 45 is 1 over root 2. Maybe I did something wrong. I'll do it again off to the side over here using this triangle. The person that was solving it said that we should do sine of 45. Were you okay with that so far? And that's opposite over hypotenuse. And if I'm going to pick this 45 for my 45, opposite will be n over 11. You with me so far? Is that what you had? So then I'm going to times by 11 on both sides. And I know you're thinking last time you had to flip the fraction, but that's because last time I was dividing by sine of 45. This time I'm timesing by sine of 45. See what I mean? Okay. So it's 11 times sine of 45, which I go get from here. There's my 45. Sine is opposite over hypotenuse, 1 over root 2. No flipping. That's because it was a fraction before. This, it's 11 times it. It's easier, less work, no flipping needed. All right. Okay. Now, wild card. This is like you can nominate any of the problems that we've practiced, because I know those are all critical. Is there any of these that you would like to see again, like the kind where blank? Is there any of these that you'd like to talk about again? Yes.
Like the kind where it gives you pi, would create the need to make a reference triangle.
Okay, absolutely. So let's do 5 pi over 3. Make a reference triangle. So first of all, figure out where pi is, then figure out where 1 pi over 3 is. Count it up. And then make me a reference triangle for 5 pi over 3. It's a good question. Well, here's pi, and here's 1/3 of the way to pi. And then if you count it up, you go, okay, then this must be 2/3 and this must be 3/3. If you get anything other than, pi there, like 3/3, then you're counting it wrong. It kind of guides you that, oh no, your wedges are too big or your wedges are too small. But mine's are just right because I know that it stopped at 3 pi over 3. So now I keep going with the same size wedge. 4 pi over 3, 5 pi over 3. So that's first, is you got to stop there. Then you drop to the x-axis. And then you know that these wedges were all 60. 60, 60, 60, 60, and 60. Okay? So then that must mean that's the right part, and this must be 30. And now I've got my reference angle, and it's 60. Make sense? Now, do you have to have sides? Yes. Opposite from the 30, you got 1, and then this is 2, and this is square root of 3, and then, oh, so close, all that work, and you forgot the negative. Is that the kind you wanted? Okay. Any other kind? Yes.
Yeah, I just have a question. What does it mean when it like says what angle's in standard position?
Okay, good question. In standard position, we just don't want you to make angles that are weird. You can make angles that are positive and negative, like that angle up there. That's not in standard position. Okay, so just make your angles always come starting here and ending somewhere else in the circle. So you can't like make your angle be like, well, I made my angle over there. You can't do that. That's the wrong way to make it. So then you can have it terminate or end anywhere. Let's say I had it end there. You'd have to know, oh, you must mean those are 45s. And so then I know that I could make a reference triangle over there. And so that's what they mean by standard positions. You always start here and then you end somewhere else. Could they give you a negative angle? Yes, we don't use them that often, but we could go negative 45. Or we could go negative pi over 4, which would be the same as 45. Remember that negatives go down? So negative 2 pi over 3 would be like, here's negative 1 pi over 3, 1/3 of the way to pi, the negative way. And this would be negative 2 pi over 3. So it'd be like there. That'd be negative 2 pi over 3. Good question about that kind of stuff. Anything else that's making you nervous about testimony? Yes?
Can you go over cosecant, secant,
So the main thing we'd expect there is that if I gave you cosecant, CSC of some angle equals, let's say, 2, that you got to know right away to go, not going to do that, but I'm going to do the other one that goes with it, like sine of the angle, and then the 2 has to be flipped equals 1/2. And then you're supposed to know from that, oh, you're talking about opposite hypotenuse. This must be this one, and then, oh, the angle you want must be the one right here, which is across from the 1, and therefore it must be like 30. So that's a typical way we test you on that, is you just have to memorize that cosecant has a sister function of sine, and when it's the sister, you got to flip it, and then you got to be able to draw it, and then you got to be able to figure out what angle that is. And usually that's going to be in radians. Is that what you meant by that question, or did you? Okay, good. All right. Any other questions? Yes?
like the converting to degrees and converting to radians?
All right, so let's say you had 210 degrees and they say convert. Well, you just got to remember to put a parenthesis, and then you got to have the 180 and the pi. Now you tell me, where do you think that 180 degrees should go?
The bottom.
Yeah, because then it'll cancel. And then the only other thing is to remember the pi goes there. And then it's just a reducing contest. Do you know how to cancel stuff? Like that cancels, and this is like dividing both by 10. And then 21 is like 7 times 3. And this is like 6 times 3. And I've replaced my 21 with a 7 times 3 and my 18 with a 6 times 3. And now I'm left with that. And can you simplify that further? So 7 pi over 6, for example. So let's do one like that where I just tell you a number. 135 degrees. Can you make that into radians? So I have a Schoology quiz that I am going to put up as optional if you want to practice that. I strongly recommend that you do the Schoology quiz. It's there like an assignment, but then that's giving you too much homework. So I'm gonna make it optional Schoology quiz today that's on this. It's because some of you are already really good at it. You're like, easy. And I know how to simplify that, no problem. The thing that makes this one hard to simplify is you gotta know how many 45s go into it. So like 135 is 3 45s. And 180 could be made into 45s also. They would be 4 45s. And if you can factor it, you should. So then these have both been factored into 3 times 44 and 45 and 4 times 45. Boop, boop, 3 pi over 4. Okay, so you multiply by a fraction. There's a great Schoology quiz to practice that one. All right, way longer, less than normal, but it's understandable considering we had a lot of topics to cover. Now, one last thing you could do. You could go watch this video. I know that seems like, well, I just did those problems. Yeah, but 6 hours from now at home when you're getting ready for the test, I just went over every single kind of problem that you, well, okay, there could be something missing from that, but like pretty much everything you need to know for the test. You should maybe look at that again. You could come in the morning for extra help, but if you're feeling really good about it, just do the worksheet and check it. Because the worksheet's a lot like the practice test. You know, in some classes they don't give you a practice test. We have told you, here's what we want you to know. Here's the practice test. You could do that tonight. Some classes would beg for, just tell me what to practice and I'll practice it. And they're like, nope, you should have taken notes. We do give you a practice test in this level of a class. If you were in honors, they get far less of that. AP also, they don't give you practice tests. I mean, I shouldn't say that. They give you a practice for the whole AP test, but they don't give you like each unit, like a practice test to study for that test. They don't do that. So use it. It's there. All right, that's all I got for you for today.